Hi, welcome back to Missing Chemistry. This is Charles' gas law problem lesson number 9. What is Charles' law? Well, Charles' law is actually written as V1 over T1 equals V2 over T2. Now, a lot of people don't like fractions, so can we fix that? Sure. All we have to do is cross multiply our variables like that, and that will give us V1 T2 equals V2 T1, which is a lot easier to do because actually most people in the world read from left to right. There are some that read from right to left, but most people go left to right. Anyway, so in Charles' law, there is one constant, and our constant right here represented by K is pressure. And then, of course, we want everything in Kelvin. So Kelvin equals Celsius plus 273.15. So let's go ahead and set this problem up. A certain gas has a volume of 1,800 liters at a temperature of 673 Kelvin. What will the new volume of the gas be if the temperature is reduced to 321 Kelvin? All right, so let's go ahead and set up our chart here. This helps us keep everything straight. V1, T1, V2, T2. Alright, so we're going ahead and we're going to identify all our variables. What are their values? So our first volume here is 1,800 liters, so that was pretty easy. Our first temperature is 673 K, which is Kelvin. Hey, guess what? We don't have to convert into Kelvin because we're already in Kelvin. What will the new volume of the gas be? So that's going to be our V2. And then our second temperature is 321 K. Notice I don't say degrees K because degrees K is wrong. Kelvin does not have degree marks. All right, so now we're going to write our formula. V1 T2 equals V2 T1. Now what we want to do is we want to do an algebraic thing where we want to isolate the variable we're trying to find. We're trying to find V2. So we're going to write this as V2 equals V1 T2. But what about the T1? It's going to go underneath the V1 T2. See that? Pretty simple. All you have to do now is put in your values. V2 equals, our first volume is 1,800 liters. And this is super simple. Our second temperature was 321 K. Oh, that was easy. Divided by our first temperature, which was 673 K. So let's cancel out our common values. Oh, they're gone. Now all we have to do is multiply 1,800 by 321 and then divide it by 673. Well, let's go ahead and get a calculator real quick. And let's go ahead and do that. Let's see here. We got 1,800 times 321. And that's going to give us a big number, which is going to be V2 equals 577,800. And that's going to be liters. And then we're going to divide that by 673. All right, so we're going to divide that number by 673. And that is going to give us 858.54 liters. So that is our second volume, 858.54 liters. That was simple. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Missing Chemistry.